Alright, we are now in Chapter 3. This section should be relatively quick because it mainly involves graphing. Hopefully no more than about 7 minutes. So, 3.1, solve linear systems by graphing. Okay, so basically we're looking at two equations in two variables. So we're looking at a system of two linear equations. Okay, another name for it is a linear system, and that is going to be your code word. Consists of two equations that can be written in the following form. Basically, ax plus by is equal to c, and dx plus ey is equal to f. And it doesn't have to be written this way. You could have it in y equals mx plus b form, but just so you know, roughly this is what it looks like. A solution to a linear system in two variables, okay, meaning x and y, is an ordered pair. X, y. Okay, and basically when you find the solution, okay, because we're going to be doing this by graphing first of all, when you find the solution, a couple things that I'm going to be looking for. You must write your answer as an ordered pair. Okay, not doing that can get you points off. And also, you must check in original equation, it doesn't matter which one you can pick, to verify it is a solution. Okay, and basically this is unless otherwise stated. Also, I'm going to go ahead and tell you, you guys may want graph paper for this section. That might be the best thing to have, but it's up to you if you actually want graph paper or not. But anyways, so that's that. So basically, you're going to be graphing two equations, finding their point of intersection, and that is the solution. Now, maybe you remember back to Algebra 1, but you don't just have to have one solution. You could have infinitely many solutions, meaning it's the same line, or you could have no solutions, meaning it is there's no intersecting points, they're parallel. So a couple definitions here really quick. Try to keep this short. Consistent. It's one solution, or I should say at least one solution. Inconsistent is no solution. Okay, so this is how we classify things. A consistent system can be independent or dependent. Independent means that there is exactly one solution. Dependent is infinitely many solutions. Okay, so basically just in pictures so you guys can see this. If it has, let's see here, we'll draw 3 graphs, leave a little space above and a little space below to write. Okay, so if I have 2 lines, okay, this point of intersection right here, okay, there. Okay, your picture should look roughly like this. This first one has exactly 1 solution. Okay, meaning that the lines intersect at 1 point. We'd say that this is consistent because it has at least 1 solution, and it's independent because it has exactly 1 solution. The second one, there is infinitely many solutions. Okay, and that is because the lines coincide, meaning they're on top of each other. Okay, or they're the same line. And this is consistent because it has 1 solution, or at least 1 solution. Sorry, I don't know why I wrote that. It's consistent, and it is dependent because it has infinitely many solutions. This last one is no solution. Okay, the lines are parallel, meaning that it is inconsistent because it's no solution. I said this, but I didn't write it. Lines are parallel, inconsistent, and that means we don't have to write anything. It's not independent or dependent because it doesn't have a solution. So it is just inconsistent. Okay, so basically things I'll be looking for you to tell me consistent and independent, consistent and dependent, or inconsistent. So be ready to graph tomorrow. Yep, that'll be basically what you have to do. And remember, you have to check your answers. Don't forget the code word that was mentioned at the beginning.